Hi everyone, we're back talking about the graph of cotangent x. So when we look at the basic graph of y equals cotan x, I'll go up here, you're going to see some similarities with tangent, but some real differences as well. One of the similarities is that the period of cotangent is also pi, because it completes one revolution in that distance of pi. So again, to find the period, you're going to use pi over b. All right, let's take a look at what this looks like. If I use my unit circle, thinking about these 4 points, and I get ready to graph the cotangent function. If I start at 0, remember that cotangent is 1 over tangent, or you could think of it as the x value over the y value. So when I start at 0, if I make this table of values now, if I start at 0, the cotangent would be x over y. It would be undefined at 0. Remember that that's not the case for tangent. Okay. Now, if I look at, let's look at pi over 4. Well, if I take the x value over the y value, that's going to be positive 1. If I look at pi over 2, and I take the x value over the y value, I get 0. And if I look at, let's look at 3 pi over 4, because we're going to go out to pi as one period. If I look at 3 pi over 4, the cotangent there is negative 1. And then finally at pi, the x over the y value here is, again, undefined. So one similarity for the cotangent function is that points 1 and 5, those first points, are vertical asymptotes here at 0 and at pi. Now the locations are different, right, because tangent goes from negative pi over 2 to positive pi over 2. Cotangent starts at the origin, though that asymptote is at 0. So though they have the same period and they both follow the pattern of starting with asymptotes, they do not have a center or beginning or end at the same point. So here at pi over 2, halfway between 0 and pi, cotangent is 0. That's right here. Now at positive pi over 4, cotangent is positive 1. At 3 pi over 4, cotangent is negative 1. So this is the pattern of cotangent. You're probably thinking it looks a lot like the tangent curve reflected, and you're right, but you have to look at where the cotangent function begins. The cotangent graph starts at the origin and completes one revolution at pi, whereas the tangent function, as we talked about, is centered at the origin, but begins at negative pi over 2 and ends at positive pi over 2. Okay, let's look at some examples here. If I want to graph y equals 2 cotangent 2x, I need to find my amplitude and figure out if there's been a reflection. No reflection, the amplitude is 2. If b is 2, then the period of this function is going to be pi over 2. Okay, so my cotangent function, which always starts at 0, will go out here to pi over 2 and have an asymptote there. The halfway point will be pi over 4. I'll look at pi over 8, and I'll look at 3 pi over 8. My vertical asymptote will be at 0. My amplitude is 2, so I'm starting at pi over 4. And cotangent function, as you may remember, starts high and goes low. So it's going to start high at 2 and finish low, hug that asymptote, and hug the asymptote to the right. That is a graph of 2 cotangent 2x. Now if I'm looking at y equals negative 5 cotangent x over 5, my amplitude here is negative 5. I'm looking at a reflection over the x-axis. I'll draw this one out here so I have a little more room. And I'm thinking about the period as pi over 1/5, which means that the period is 5 pi. So I'm starting at 0. My right-hand asymptote will be at 5 pi. My left-hand one will be at 0. Halfway between those is 2.5 pi, so I'm going to call that 5 pi over 2. Halfway to those, well, if I take 5 pi over 2 and I divide it by 2, that's the same thing as taking 5 pi over 2 and multiplying it by 1/2. So I'm looking at 5 pi over 4, and I'm looking at 5 pi, 10 pi, 15 pi over 4. Okay, now the amplitude is going to be 5, and I just have to be careful to reflect this. My center point is going to be 0, and rather than going high to low, now because it's a reflection, I'm going to go low to high, and the graph of -5 cotangent x over 5 looks like this. Okay, happy graphing!